Okay, so we are looking at the gradient of a line, and the learning intention here is to find the gradient of a straight line and to understand or to figure out that what we mean by gradient is a ratio to start with. It's the change in vertical height divided by a change in horizontal distance. Okay, so if you were a lorry driver, what does that mean? If you were going up a hill for a certain amount of miles or something, the gradient is just that height divided by that length here, journey. Again, you can see, looks like triangle is getting back in, and we've got a right angle triangle, so they're everywhere. So that's what the gradient is. It's this height divided by this distance here. Okay. And as a lorry driver, for example, you would like to know how steep an incline of a mountain is, for example, because sometimes you won't be able to go up the mountain. And you've got signs posted, especially if you go to Europe, they would show you something like this, and they would say this is 10%. So that means for every 100 meter that you would go along the way, you would climb by 10 meter. Okay, so that's what it is. And hopefully we'll be able to calculate some simple gradient. So basically gradient, that's the measure of steepness of a line. It's a change in vertical height divided by the change in horizontal distance. And sometimes you see it written as V for vertical divided by height by H for horizontal. Okay, so that's how they define the gradient. As you can see, it's a ratio. The height is going to be in meter. The distance is going to be a meter. So what's M divided by M?
M.
Do you remember what we said? Anything divided by the same thing is always
1.
1. And that's how we've managed to simplify things, because we just go X divided by X. We go, oh, that's gone. We've been doing that, and we replace that with 1. So that's the same thing when you divide a meter by a meter, you get a 1. And that's why the gradient has got no unit. It is a ratio. Okay, remember when we did the circumference of a circle, we said C equal pi d. Remember that?
Yeah.
And we said, okay, if C equal pi d, that means pi equal C divided by d. Do you agree?
Yes. We bring the D across.
Yeah. So you bring d across, or you divide by d each side. And pi doesn't have a unit because it's a distance divided by another distance. So whatever unit you've got there is the same unit that you've got at the bottom, and pi is just a ratio. That's why you'll never see pi written as 3.14 meter, for example. It's always 3.14. It's the same for a gradient, doesn't have a unit, okay? So, difference in y coordinates, if you were to represent something in x and y, so you've got difference in height of a difference in x coordinate, difference in x's, and the steeper a line is, the bigger the gradient. Yeah?
Yep.
So if I've got a gradient of 1, for example, that means for every 1 meter I'm going up the way, I'm going to travel 1 meter to that distance. So that's how steep that is. 1 divided by 1. But if I've got 10 meter up on a 1 meter along, so you can see this is much steeper.
Yeah.
Because this is 10 divided by 1, for example. Okay. So the steeper the line, the longer, the higher, the bigger the number. So let's say we've got this line here. I've got 4 units
0, 4.
in X and 3 units in Y, because we go from 0 to 4 on the X-axis and from 0 to 3 on the Y-axis. So for this line, you would write that the gradient is M, and you would just say it's V divided by H. So vertical, we've got 3 units. You just write 3. And on the horizontal side, we've got 4 units there, which is divided by 4. So 3 units divided by 4 units. Units and units cancel each other. We've got a gradient that has got no unit this time, but it's just 3/4. Okay? So basically, if I was to travel 4 meters along a line with this gradient, I would go up by 3 meters. Yeah?
Yep.
Quite easy enough. Vertical divided by horizontal. So now I've got a second line. So this time there's my line. Remember, we need to try and see if we can see a triangle associated with it in order to find. So I've got here a distance and here another distance. So we said it was vertical divided by horizontal. So what is the vertical distance here? What,
Between
3
2.
over
2,
2.
3, yeah, and 3 over 2,
3.
yeah. So basically the gradient for this line is 3 divided by 2. Okay, so the mistake that sometimes you see people would go as, oh, this is 5 and this is -3. So no, you need to build back your triangle and see how much you're going up by along how, you know, how long you've been going along with. And that's why it's 3 divided by 2. So let's have a look at another one. So far, we've looked at these 2 lines. So there's the green line here. Again, so you write vertical divided by horizontal. So a vertical climb of, so remember to put your triangle there. I'm going to change that color. So you would go along here horizontally. I'm going by 1, 2, 3, 4, 5 squares, or 5 units, and 1, 2, 3 on the vertical. So that would mean 3 divided by 5. Okay. And if you've got your calculator, 3/4 is 0.75. 3 over 2 is 1.5. So straight away, you can tell me that the second one here, the red one, is steeper than the blue one by just looking at the gradient value. 3 divided by 5 is 0.6. So you can tell me as well that the blue one is steeper than the green one. You can see as well. So you've traveled 5 unit lengths along to climb by 3. Here you've only traveled 4 to climb by 3. So that is steeper. Okay. So the other place you might see steepness get into play if you buy a ladder, for example. On the ladder, there's sometimes a small, especially for the professional, they put like a small tab to tell them exactly for how high can you go and what is the gradient that they could use on this ladder, depending on how much weight they're putting on. It's just for safety reason. So it's something we never check because we're probably not professionals, but it is there to protect us. So far we've got 1, 2, 3 positive gradients. Okay, it's because we're going up. So when we go down, the gradient becomes negative this time. So it's the rule that they wanted to show. So if you're going up a hill, you've got a positive gradient. But if you're coming down, and again, if you're a lorry driver, for example, if you are in mountains, they'll give you the gradient a percentage but it's a negative one this time. So it's -2 in vertical. So you're going down by 2 as you're going along by 6.
Okay.
Whereas here you were going up by 3. Because we're going up, it's positive. Here we're going down, it's negative.
Cross by 6.
Divide by 6, yeah. But again, a fraction, do we leave it like that? Or can we simplify it?
3.
Yeah, so basically, they're both in the 2 timetable. That's the first thing you should say to yourself. I've got 2 even numbers. They both go into the 2 timetable. That means I can divide my top by 2 and my bottom by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. And your final answer should be -1/3, or a negative third. So if someone tells me I've got a gradient of -1/3, I know that this is going down, and for every 1 step, I'll be going down along by 3. Can you see that? 1/3. So that line there, if I had stopped there, I could have given you the gradient. 2, you'll go 6. If I go 3, you'll go 9. Yeah. So that ratio is the same. So no matter how long your line is, the gradient will always be the same. Okay. So that's important. So the aim of the game today is to try and get a gradient if we are given 2 points, because you're going to be asked to put coordinates, for example, on an X and Y diagram. So you've got X axis and Y axis. So they'll give you 2 points and they're going to ask you, what is the gradient between those 2 points? Or if you were to draw a line between the 2 points, what gradient would you get? Okay, so that's the typical type of question you get in Nat 5. So let's try and see if we can figure out using x2, y2, and xy, y1 how to measure or how to calculate the gradient. So the first thing here, you've got the first point here, x1, y1. x1 is that distance there, and y1 is that distance there. So when you're asked to plot a point, you go x1, x could be equal to 2, so you would go 1, 2, and y1 could be 1, 2, 3. So those coordinates would be 2, 3, and that's what it represents. The one thing you need to remember is if you're asked to put x and y coordinates and to draw the coordinates, make sure that the units that you use or each interval here are exactly the same all along, consistently, and that interval here is exactly the same for x as well. Okay, so if you use like v-squares, or if you use 1 centimeter ruler, another centimeter, so you would make sure that that first centimeter is the next centimeter. So that's how you would draw x and y coordinates. Okay, so that's important to remember. The next point I've got given is x2, y2. So that's my x2. So that's distance there. So that could have been 1, 2, 3, 4, 5, 6, for example, x2. And then 1, 2, 3, 4, 5, 6, and 7 for y2. This is just an example, okay? Now, what did we say for the gradient? It's the vertical height here divided by the horizontal distance. But if you look at it, yeah, so if you look at it, you've got x2, which is that length, and x1, that length. So that distance there is x2, take away x1.
Yeah.
And the same happen on this side. You've got y2 minus y1. So that means if I'm given 2 points and I know the coordinates of each point, I can calculate my gradient because my vertical height is going to be y2 minus y1, and the horizontal distance here is just going to be x2 minus x1. So your gradient is a formula that people usually learn by heart, but you can find it back if you can plot your points and you know what a gradient is. It's vertical divided by horizontal. So you'll hear a lot of students would just tell you, oh, gradient m is just y2 minus y1 divided by x2 minus x1. But if you know where it comes from, I can guarantee you've got more chance to remember it than learning it by heart. Because so many would just eventually, during the exam, write x2 minus x1 because they can't remember it's a vertical divided by a horizontal. Whereas if you know where it is, you've got your explanations, okay? So that's important to understand what you do and why it is like this. So that's the first formula that we will learn today. So the gradient formula is m equal y2 minus y1 divided by x2 minus x1. And I've got a wee notepad here to say that it's probably something that you would need to write down because it's an important formula. Whether you remember it by heart because you're going to do it quite a few times, or you can bring it back through your vertical divide by a horizontal, it's up to you.
These quite common in the exam, I'm assuming. Yeah, they're quite, they do come.
Calculate the gradient of this straight line. I've not seen a paper without them asking it.
Right, okay.
So that's why a lot of people would learn it by heart, but I would rather you guys see where it's coming from. And then you've got an idea, what is a gradient? A gradient, that's a steepness. Where can I use it in real life? Mountain, roads, roof, ladders. Everywhere you go, there are gradient. We don't call it like that because we just, okay.
You wouldn't tend to call it that?
No,
normally.
Yeah, exactly. If you've got a painter coming to paint your eaves or whatever, don't tell him, oh, but make sure your gradient is correct before you go up. He's going to have a laugh at you.
I usually just ask for a cup of tea or coffee, but there you go.
Okay. Okay, so like I said, a line sloping up from left to right, we call it a positive gradient because remember we're going up divided, whereas if the line is sloping down from left to right, we did say that was a negative gradient. So when you're going down, it's negative. When you're going up, just think about everything up is positive. Okay. So there's another thing like people, so you don't need to remember it just now. We'll talk about it again. So whenever you see people telling you about, oh, I've got two lines, they've got the same gradients, that means the two lines will never touch each other unless they're the same line. Okay. So if they've got the same gradient, the two lines, we say they're parallel. So we'll come back to that. So here, this is just a quick summary. A positive gradient, so you can sketch that, m greater than 0. A negative gradient, you can see it's going down, so going up, going down. Now, if it's neither positive nor negative, then that means it's 0 itself. So if you've got a straight horizontal line, the gradient is 0. So this is an important one because they might say to you, I've got the equation of a line y equal a number y equal 5, and you might say to yourself, how come that is a line? Y equal 5 can't be a line because y equal 5 is just an integer, like a value. But what they didn't tell you is it's a line because it's got a gradient of 0. That means you're not going up or going down. You're just staying straight on the line, cutting the y-axis at coordinate 5. So it's a straight line. And if you were to plot y and x there, so there's your x-axis and your y-axis. It's just a straight line going through value 5. For any x, y is always equal to 5. Okay? So if I've got another line, y equal 3, they both got the same gradient because they're both straight lines. And you can see that the gradient is 0 for both. Those two lines are parallel. They will never meet. Okay? So because we spoke about a horizontal line, it'd be good to talk about a vertical line. So a vertical line, this time, is going to be x equal a, but the gradient is undefined. Okay, so why did it have to come by saying the gradient is undefined? You could have said to me, oh, that's infinity then, because you just keep going up, or negative infinity. So they say the gradient is undefined because you can't divide by 0. So basically, you see that x1 minus x2, because it's always the same x, you'll get a minus a. So if you use your calculator and do any number divided by 0, your calculator will come back with a math error. And because it's mathematically impossible to divide by 0, they call this gradient an undefined gradient. Okay? So plus v just means positive. M minus v just means negative. So sometimes you see people calling it plus v gradient or minus v, so it just means negative. Or that sign greater than 0, less than 0. Horizontal line, we just said, has 0 gradient. And a vertical line has an undefined gradient. So now you know everything about straight lines. Okay, so I've not given you the formula of the straight line yet, but at the moment we're looking at gradient in this chapter. Okay, are you still writing? Sorry.
Yeah, 2 seconds.
It's okay.
Oh. Right, okay, you can go. Sorry.
So but remember, I'll be sending these as well. So even if you don't finish writing everything, but so positive, negative, 0, or undefined. These are the 4 types of gradient you will get. So now let's say someone gives you something like this. You've been given on the left. So we'll look at the left first. Oh, it's up to you. We can look at the right first. I'm not sure actually. Yeah, we look at the right first. So you've got a point 1, 2, and another point 3, 8. Whenever this is given to you, and they ask you what is the gradient of that line, the first thing you need to write is m equal y2 minus y1 divided by x2 minus x1. So the next bit is to be careful. You need to pick what is x1, what is y1, what is x2, what is y2. So what I would say to my student is, you have got the choice. Is it easier to deal with positive numbers or negative numbers?
Positive.
Positive numbers. So That means, ideally, if that first one was bigger than the second one, I would get a positive at the top. Because this is y and y. Why do I pick 8 as my y2? Because I know if I do 8 minus 2, which is my y1 here, I'm going to get a positive number. Eight minus 2, that's 6. 3 minus 1 is 2. 6 divided by 2 is easier than negative 6 divided by negative 2. Yeah?
Yep.
But again, it's up to you. You've got the choice. You can decide that instead of using y2 8, you could have used y2 2. You will get the same answer, but this time we will get 2 minus 8, for example, if I had picked the other way around, and then 1 minus 3. But then that means 2 minus 8 is negative 6. 1 minus 3 is negative 2. So what's negative 6 divided by negative 2?
3.
Yeah, a positive 3. So you need to remember that. Whereas if I tell you what's 6 divided by 2, it's easier to think about, oh, I've got some negative to deal with. So that's why we do it this way. We pick the numbers that we think are going to be easier to manipulate, to do the so x2, y2 are going to be these two numbers. x1, y1 are going to be my two numbers here. So it's usually a good thing to write underneath them so that at least now you know you've got to do that minus this one divided by this one minus this one. Some people do them, in their head, but I would argue that it's safer to just write it. And then eventually you've got your 6 divided by 2, which is 3. Then you think, if for some reason I had a negative value here, what did we say? Something going up is always positive. So then you would say to yourself, oh, there's somewhere maybe I've made a mistake. If you had come back to me and told me, oh, this is negative 3, then that means you don't understand what the positive steepness is or a negative steepness is. Going up, positive. Coming down, negative. Okay. So now we're going to do the negative one. So hopefully we will get a negative value. So this time, y2 is this value here, 8. And x2 is this one here. And x1 is this one. And y1 is this one. So 8 minus 2 is 6. Negative 3 minus negative 1. A minus makes it a positive 1. So you get 8 minus 2, 6, minus 3 plus 1, which is minus 2. And 6 divided by minus 2 is just minus 3. And that makes sense because I'm going down the way and I've got a negative gradient. And if you can see, the steepness is the same. It's just one is going up, the other one is coming down with the same steepness. And if you were asked, are those two lines parallel? No, because one is positive, one is negative. And you can see that if we were to keep drawing them all along, you will cross them. Whereas two parallel lines never meet. Okay?
Yep.
Yeah.
So let's try some examples. So this is for your homework. so that you can practice. So page 61. Exercise 8A, question 1 and question 4. But for those who's not got the Lecky book yet, remember, you can't share basically those PowerPoints because I don't have the intellectual property to be able to paste a book that I've bought myself, okay? So I'm doing this because I've managed to copy the book in a PDF format. But you can't share it because I'll be in trouble if that goes into the wrong hands. Okay, so calculate the gradient of the straight line joining the following pairs of points. So we're going to do a couple so that you can do the rest. So let's say we'll do an easy one, or I hope usually those exercises are put from the hardest, from the easiest to the hardest, and we do a kind of hardish one towards the end. This shouldn't be that hard. So I'm going to decide C x1, y1 and x2, y2. So I'm looking at this. I know m is y2, m equal y2 minus y1, remember? Divided by x1 divided by x2 minus x1. So the easiest thing to do for me here is, what if I pick y2 to become 6, because 6 is bigger than 4, and that means this is x2. And I've got here x1, which is 0, and y1, 4. So my first one here would be 6 minus 4 divided by negative 1 minus 0, so it's just negative 1. 6 minus 4 is 2. 2 divided by negative 1 is just negative 2. Because 2 divided by 1 is 2. 2 divided by negative 1 is negative 2. So I've got a slope here coming down the way. And if you've got some time, whenever you ask a question like this, what you could do is get yourself your ruler out, do -1, 6, 1, 2, 3, 4, 5, 6, that's about here. 0 on X, 4 on Y, which is about here. So I've got my two points, and if you draw a line through those 2 points, you can see straight away it's got a negative gradient. So even by doing whatever you've been doing, by putting together a small X and Y coordinate, you can check that your answer makes sense. This is negative because my lines is coming down. Yeah?
Mhm.
Or if the worst come to the worst, you can't remember this y2 minus y1, draw those two, find out what the vertical is and what the horizontal is, and you'll find out that you've got a -2 divided by 1. And that is your gradient. So you will get the mark by doing it that way. And I'll give more credit to a person that went and did the wee graph because they couldn't remember the formula by heart and knows that a gradient is a vertical divided by a horizontal. and gave me the answer that way, you will get the mark. And in my eyes, you are not someone learning everything by heart because you understand what you're doing. Because when I've got someone that understands what is doing, I'll trust that person to be able to solve problems. Okay, so
Yeah.
there are infinities of ways to be able to get an answer, especially if we can't remember things by heart. So the next one, but obviously because of time, sometimes it's good to know things by heart because then you can get more marks. So for the next one, I've got x1, y1, x2, y2, or we can decide to do this is y1 or y2. It's up to you. So we can just use x1 and y1 for this one. And x2, y2 for this one. So we said y2 is negative 8. So I need to write minus 8 minus y1, so minus 4, divided by x2, minus 2, minus 11, that will become plus 11. So minus 11. We arrange all this, we get negative 12 at the top, negative 8, negative 4 is negative 12. And at the bottom, I've got 2 plus 11, which is just 9. Do I leave it like that? Unfortunately, we don't get the mark if we leave it like that. Even if you can't remember that this is a 3 timetable for both of them, you can do 2 plus 1, that's 3. That tells you straight away I've got a multiple of 3 here. That means hopefully you remember that 3 times 3 is 9. So 12 divided by 3 is 4. So minus 4. 9 divided by 3 is 3. And now you get your full mark. Okay, so if this was like 2 marks and you stop here, unfortunately you would only get 1 mark. You need to simplify it further. And again, if it was me doing this and I've got 5 minutes left at the end, I would go x minus 11, 4. So I'm about here for that point. X minus 2, I'm about here. Minus 8, I'm about down there. So you can see again, this is a negative gradient. Okay. So I'll let you do the other ones. I think once you've practiced, the good thing about this is it's got a lot of integers practice, so you'll be able to do them and then check quickly on the side of your paper if you've got a positive or a negative gradient, because that's usually what trips folks, is with so many minus of a minus and plus and minus that they get, you know, a positive or a negative. But because you've got the points, you can quickly check if it should be a positive or a negative one. Basically, you've got no excuses. Okay. So, I think we're gonna, yeah, so let me see, yeah. On this one, it's just doing the same thing, but using fractions. So I think I'll let you practice these two. There's no point in me going through 50% of these because if I do a gradient here, I've already done half the job. So I would rather you guys try them, work with fractions, and that way it's through the struggle that you will learn better. Okay. So I'll let you do these. And we've learned how to add. If you struggle with this, you can always go back to the starter question. How do we do kiss and smile? If I've got a fraction at the top divided by a fraction at the bottom, you time it by flipping the one at the bottom. So all these will use fraction work. Okay. And then we can take a 5 minutes break, I think. Yeah. Okay. So yeah, before we go, what I'll do is I'm just going to explain you, yeah, how to solve these wee problems. So here I've been given the gradient of 2. Okay, so I'm going to just brief you onto this one. A gradient has been given, MAB, so the gradient between point A and B is 2. And we've learned that if I've got x1 for my first point and y1, for my second point, I've got x2 here and y2. Yeah?
Yeah.
Gradient is y2 minus y1. This time I've got y minus 1. Remember why we were doing all these algebraic fractions? Because there they come. This time I'm using letters. And x2 minus x1, 8 minus 5, which is just 3, right? So y minus 1 divided by 3. Now the question is, can you see the question there? Find y. They've just asked you to solve this equation. Solve y minus 1 divided by 3 equal to. To do this, the first thing you do is you need to get rid of that 3. The fraction sign just means divide by 3. What's the opposite of dividing by 3? Multiply by 3. So if I multiply by 3 this side, and I multiply by, when you do this, because you've got an equation, you need to multiply by 3 the other side. That will get rid of that fraction. Yeah? So 3 times y minus 1 divided by 3. 3 divided by 3 is 1. So you end up with y minus 1 on that side equal, what's 3 times 2? 6. Now you can see what y is. What is the opposite of taking away 1?
Add.
So I add 1 here,
Mhm.
and I add 1 here, and I've got my y. Because if you add 1 and take away 1, those disappear. Y equal 6 plus 1, which is
7.
7. Okay, so that was the question. Find y if the gradient is 2. To get a gradient of 2 between those 2 points, I need to have y equals 7. Do you stop here? Not really. I've got 7 there. 7 minus 1.
6.
6. 6 divided by 3.
2.
2, which is what I was looking for.
Yes.
That extra 5 seconds of me checking this, I came out this test or exam or whatever you call it, knowing that this is the right value. Because I just took 5 seconds to plug it back in, checking that that makes sense. Okay? And for question 6, it's similar, but instead of looking for a y, they ask you to find an x. but you just adopt the same approach. Okay? So this is a wee problem solving, which is asking you to solve equations, to work with algebraic fractions, to work with a bit of fractions on itself, and eventually to get the gradient. So all the lessons that we've been looking at for the past so many weeks, you can see all getting mingled together to just draw a problem. So we're going to take a 5 minutes break, guys.